Welcome to my projectbazaar.com. Now let us discuss about the diversity-multiplexing trade-off optimal low complexity zero forcing method based on ZPOFDM. Let us discuss about the abstract of the product. Due to the computational complexity of maximum likelihood signal decoding, the equalizers with less complexity are considered in the literature. Employing the zero forcing equalizer, zero padded orthogonal frequency division multiplexing is capable of benefiting the maximum available multipath diversity with the computational complexity of inverting a matrix of the size of data block length with incurious extra implementation cost relative to the fast Fourier transform based OFDM decoder. A maximum likelihood equalizer is computational complexity. So here the proposed work is to reduce the complexity zero forcing equalizer based on the ZPOFDM is used, and also it obtained the maximum multipath diversity. Reduce complexity zero forcing is the transmission scheme and propose a reduced complexity of two-stage algorithm is used to decode the received data OFDM signal using a zero padding interval interval in the transmitter side. Zero padding consists of appending zeros to a signal in the OFDM process to obtain the maximum multipath diversity and reduce the complexity by using the zero forcing equalizer, adding in the receiver side model. So let us discuss about the product of the flow diagram. Initially, input signal is generated randomly by using the conventional encoding as a type of correcting code that generates parity symbol via the sliding application of a Boolean polynomial function into a data stream. In serial to parallel conversion, this additional processing is necessary to convert a serial bit stream into several parallel bit streams to divide it among the individual carriers. Next, the interleaving coded data is a technique used for controlling errors in data streams over the unreliable or noisy communication channels, and then the binary bit stream is converted into a decimal, and then a QAM is a quadrature amplitude modulation as a type of method is both an analog and digital communication scheme into a signal channel. Thereby a doubling of the bandwidth, QAM is used especially in wireless application. It is maximize the spectrum efficiency by minimizing the error rate. And then the pilot carrier insertion. A pilot carrier is a signal. It is usually a single frequency transmitted over a communication system for control purpose. Modulation with the IFFT, that is a inverse Fourier transform function. The modulation of data into a complex waveform occurs at the inverse Fourier transform stage of the transmitter. Here the modulation schemes can be independently of the specific channel being used and can be chosen based on the channel requirement. In fact, it is possible for each individual subcarrier to use a different modulation scheme. The role of IFFT is to modulate each subchannel on the appropriate carrier. This is the zero padding. To adding the zero padding, for implementing the zero padding consists of signal appending zeros to a signal up to the transmitter is over a channel. Next we discuss about the channel of the product. So channel is the AWGN Rayleigh fatting channel is used for in the product. In the receiver side, reversal ZP OFDM transmitter process or perform. Additionally, adding the zero forcing equalizer is used for reducing the complexity. Implement a demodulation scheme by using a QAM demodulator and vector B decoding for the demodulated signal. Finally, calculating the BR, SER and the outage probability of the system. Here we discuss about the running procedure for the product. Select the main m.dot file for executing the product. Now by executing the file, many outputs are displayed. All the outputs are related to our flow diagram for both the transmitter and the receiver side. The transmitter side first generating the input data. So this is the input data of the system, and then encoding the data it's displayed. So the encoding data is this is the encoding data. So this is the encoding data of the product. Similarly, all the results are displayed related to the flow diagram process. At the receiver side, reversal operation of the transmitter side process are performed. That output also generate. Finally, we analyze the results of BR, FCR and the outage probability of the outputs. So in the ACR, this is a output graph for ACR. So SNR versus ACR. This is a symbol error rate comparison of 64 QA modulation with different decoding scheme. This is our proposed one. These are our existing system. So comparing to all the existing system, our proposed one is very minimized. So this is the SNR versus ACR, and all comparing to all the existing results, that is ZP, AC and CP. Compared to all the result, RCZ graph is minimized. The next result is shown in a bit error rate. So this is the bit error rate product. So the bit error comparison of 64 QA modulation with different decoding scheme. This is SNR versus BER. In this graph also, our proposed one is to minimize compared to all the existing results. So finally the next one is the outage probability of the. So this is the outage probability graph, the SNR versus outage probability. So the outage probability comparison for different decoding scheme. In this result also, proposed work is to minimize compared to all the existing results. So finally these are the ACR, BER and outage probability result to achieve the maximum multi-part diversity. So that's all about the running procedure for the product. Thank you for listening this video.